Hey guys, and welcome back for our introductory lesson to Surds. My name is Miss Danielson, and I hope you joined us for our previous lessons on factors, particularly prime factors, as well as squares and square roots. If you missed those lessons, I'm linking them down in the description box for you below, because those topics are linked to this one. However, Surds may be something a bit new for you, but don't be afraid, because a fear of Surds is the definition of an irrational fear. Okay, that was a bad joke. Let's get into this. If you like bad jokes and you actually want to understand that, it would help if you knew what surds were. First of all, surds are irrational numbers. So that's not this 7 here. 7 might be considered a prime number because it only has two factors, one in itself, but it's not an irrational number. -8 is also not an irrational number. -8 is a negative number, but it's not irrational. Let's take this one step further to explain what irrational means. Irrational numbers are not rational numbers. That is, they are not numbers that can be accurately expressed in fraction form. So a half, for example, is a fraction. So that's a rational number. 0.25 is a decimal value, which could be written as the fraction a quarter. So that's a rational value as well. The square root of 9 is actually positive or -3, which is an integer. It's a whole number, either positive or negative. And whole numbers like 3 and 7 could be written as fractions over 1. So those are not irrational numbers. The square root of a non-square number, however, like the square root of 3, that's an irrational number. If you try it on your calculator, you'll see that you get a very long decimal answer that never ends and doesn't have any kind of pattern in it, so it's not recurring. That's what we call an irrational number. So now that we understand what rational and irrational means, surd terms can consist of two parts, a rational part and an irrational part. Just to be clear about this, a term is an expression which is separated from other expressions by either a plus or a minus sign. So for example, 3 root 6. This is a surd term which consists of a rational part, now that's the 3, and an irrational part, the root 6. We could also write this as 3 times root 6, because when we put a number in front of a variable like 3x, that means 3 times x. In the same way as when we put a rational value in front of an irrational value with no plus or minus sign, that means multiply. To simplify surd terms means to factor out the largest possible rational part. For example, the square root of 80. If you put square root 80 on your calculator, you'll get an irrational number. That is, you'll get a decimal number that is very long, in fact it goes on forever, with no obvious repeating pattern. However, the square root of 80 can be simplified. There are some factors of 80, which are square numbers. So step 1 is to find the largest square factor of this value. Step 2 is to rewrite the value as a product of this square factor and its factor pair. So 80 is the same thing as 16, which is a square number, multiplied by 5. So if I'm trying to square root 80, and I know I can't because it's not a square number, I can break it down into two numbers, and one of those numbers I know that I can square root. Step 3 is to square root the square factor, leaving the non-squared factor under the square root sign. So that's going to be our irrational part. The square root of 16, which we know is a square number, is 4. So this will simplify to be 4 square root 5. The 5 couldn't be square rooted, so that's left as our irrational part of this surd term. Now 5 is a prime number, so I can't break it down into a square factor and a non-square factor to simplify this term any further. The square root of 80 can be simplified to be 4 root 5. When we get to big numbers like 384, for example, it might be difficult to simplify this surd term. So prime factors might be helpful for this. Try drawing a prime factor tree. If you're not familiar with this, check the description box down below. I've got lessons on that for you. Starting with the number 384, our prime factor tree splits this off into its prime factors and their factor pairs. So starting with the smallest prime number I know I can divide this by, 384 divided by 2 gives me 192. Now the 2 is prime, so I'm going to leave that branch for now, and I'm going to continue branching from the 192. 192 can also be divided by a prime number. It divides by 2, and the answer is 96. Now 96 is not prime, so we need to continue from there. The 2 is prime, so we'll leave that alone. 96 again does divide by 2, and the answer is 48. Let's keep going. 48 divides by 2, and the answer is 24. 24 also divides by 2, and the answer is 12. 12 also divides by 2, and the answer is 6. Now we don't always divide by 2, but we'll continue dividing by small prime factors until we get to a prime answer. And the smallest prime factor I can think of is 2. 6 also divides by 2, and the answer is 3. Now 3 is another prime number, so we can stop there. You can see that 384 is equal to 2 times 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 3. That is 1, 2, 3, 4, 5, 6, 7 2's. That's 2 to the power of 7 times 3. Now I'm not going to group that together and write 2 to the power of 7 times 3 because my objective here was to see if I could find a square number that we can divide 384 by. I can see that I have prime factors 2 times 2 times 2 multiplied by prime factors 2 times 2 times 2. When we multiply a value by itself, we get a square number. So basically we've got here 8 times 8, which is 8 squared, multiplied by the non-prime factor pair, 6. So 384 is the same thing as 8 squared times 6. So we can square root the square part. The square root of 8 squared is obviously 8. And the non-square part remains the irrational part of my surd term. It stays square root 6. So the square root of 384 simplifies in surd form to be 8 square root 6. Now just take a minute to copy that down, let that sink in, and let's move on to the practice. Write these values in simplified surd form. So split these values into a squared factor and its factor pair. Put them both under the square root sign and square root the square factor, leaving the non-square factor under the square root sign as your irrational part. Make sure you factor out the biggest square factor. Otherwise, you'll be left with an irrational bit under the square root, which could still be partially simplified. Go ahead and hit pause now so you can copy down those questions. Use factor trees if that helps, and hit play when you're ready to take this up. I hope you had a chance to hit pause and you did this without a calculator. Here come your answers. For question 1, the square root of 27 is the same as the square root of 9 times the square root of 3. 9 can obviously be square rooted, that's 3 root 3. The square root of 48 is the square root of 16 times the square root of 3, which is 4 root 3. Be careful, it's not just 2 root 12. Some people might have said that 48 is the same thing as 4 times 12. That's true, but 4 is not the highest square factor of 48. 16 is. If you look at that irrational part there, 12 is the same thing as 4 times 3. So we could have simplified that a second time, and we would have ended up with 2 root 4 root 3, and the 4 can be squared to make 2. So that would be 2 times 2, which is 4 root 3. Next, question 3. Question 4. Question 5. Question 6 is already simplified. 414 doesn't have any square factors. Question 7. Question 8. Question 9. And question 10. Now, how did you do? Were you able to do all of that without a calculator? If so, great job. If not, please leave me a comment down in the comment section. There is no sense in cheating and using your calculator. Although some scientific calculators will do this for you, you do need to understand the theory behind it. Many exam questions try to fool you by giving you algebraic examples of this. So thank you for joining me for this lesson, and keep an eye out for our future lessons on simplifying surd expressions. Until then, keep practicing, and I'll see you soon.